Hello everyone, my name is Prof Ramutsindela. I'm the Dean of Science. It is my pleasure to meet you all online, both applicants and parents. I want to thank you for applying to study in the Science faculty at the University of Cape Town. You did so knowing fully that we are living in uncertain times, but you had confidence in applying to the University of Cape Town. So I want to thank you for doing that. In this presentation, I'm going to share with you three things. First is to share my thoughts with you about science and society. And I will also then take you on a tour of the fields of science at UCT. You will have the opportunity to ask questions at the end of the presentation. And we will do our best to try and answer your questions. So you have decided to come and study science at UCT, but what is science? What is science about? Science is about a number of things. One is the wonder, the creativity that comes with that wonder. So we always wonder why things are as they are. You know, where the clouds come from, where do they go? It is also something that challenges us to be creative, to be able to think through the challenges we have and how we could solve them. But the world around us is full of wonders, and we try to understand how our world is made and our place in the world. But we also use science to work things out, to try and find out why things work the way they do, to study their workings, to study their lives. But more importantly, we use science to solve problems. There are many problems in the world, as we know, and we use science to try and solve the problems. But I want to talk to you this evening on the subject of using science to improve the quality of life. In the history of science, so much has been triggered by the problems that society faced. And so one should think of science and human well-being. In the 21st century, we have become so dependent on science to ensure our longer and healthier lives. We have studied how our bodies work, and we know exactly how to sustain them. In the past and in the absence of science, life was at times shorter because people did not know what to do. In the 21st century, we can monitor our health. Very often we see people jogging. They can monitor how their health is. But sometimes we forget that science also makes life fun, that we can enjoy the beauty of nature. And if one goes to the United Nations Educational, Scientific and Cultural Organization's website, UNESCO, there are quite a number of aspects where science is seen to have been used for human well-being. But we also use science to meet societal needs and to tackle global challenges. One of the global challenges of our time has been the COVID-19. And this, for all of us, challenges our human survival. So we have to think about viruses perhaps in a more serious way than before. Even people who are not doing science in the sense of going to the laboratories, they now have had some mentions of viruses. They have to learn what is it that is causing the problem that we see. And the other key challenges of our time is inequalities. And one has to think about where inequalities come from. Part of the source of inequality has been the advancement of science, which has meant that other groups of societies were left behind. I could just give one example. Mining, which most of us will know in this country. Mining required scientific developments that will enable humanity to reach far deep into the ground to take out the minerals. And mining has been very key in the development of the economy in this country. But obviously the economy has not benefited everyone who lives even in the mining areas. And the example of Marikana comes readily to mind here, where people are living just where the mining is taking place, but their life hasn't improved. But it will also take science to provide solutions. Using mining again as an example, we have so many casualties in mining. We've lost mine workers trying to dig out and retrieve the wealth which is underground. But what has happened in many other countries is that they've used technology to try and alleviate some of these tragedies. We have also learned that when society changes, we also see changes in science. So in many ways, science responds to societal changes. And I can give examples of how the wars that have been fought in the past, could be the First World War, the Second World War, they have triggered some of the scientific discoveries that we now appreciate. So if you think of nuclear energy and how nuclear physics have developed from that, it was basically trying to respond to the need of wars. More recently, I've learned from my colleagues in computer science that computer science actually emerged as a result of the need to save life. So there's the history of science, which is important in responding to human needs and challenges. And in the 21st century, these needs and challenges have increased. And so our science should step up to that challenge. One of the examples that I can give is resource consumption. I think the human population has not only increased, but we have got so much consumptions of natural resources that we're beginning to see huge problems. Water consumptions, for instance, has meant that in many parts of the world, there have been crises related to water. Power has been a critical aspect. Human population has increased, and the demand for power has also increased. But how do we step up to that demand? We would need science to provide solutions. And one simple solution which has come out with regard to energy has been the renewable energy, which is now being seen as a solution. We have seen the global movement to move to this kind of energy for both human survival and for the health of the planet. So these few examples do tell a common story that science has got a role to play in society. And those who are interested in science have got their role to play in society. But we don't necessarily have to keep science within the laboratories. We will need to take science to the streets to share scientific knowledge with other population groups, with ordinary people who might be interested in what we do. And at UCT, we have the experience of getting our science to the streets. The example that you see, it's one of those areas where ordinary scientists, students in particular, are involved in getting our science to the streets. But of course, we also use our science to tackle some of the local problems. And it is for students in science and their professors to demonstrate their knowledge by solving some of the problems at the local level. We also have to excite the schools who need to be aware of what science offers. So at UCT, in the science faculty, we do have programs that go to school, and we might not have been able to come to your school this year for the reasons that we all know, but we have always tried, and we'll keep trying, to get science to the schools. Now, I've given you some thoughts about what science can do and what we do with science, but how is science offered at UCT? What kind of science do we offer at UCT? And I want to give you some thoughts about that. So at UCT, we we have got three classes of disciplines. One is biology, earth, and environmental sciences. So for those of you who are interested in those areas, we do have a range of disciplines which I'll show you later. We also have chemical and molecular sciences that are grouped together to allow students to go deeper into understanding this kind of sciences. We have the numerical sciences, and I will show you how these clusters are made up of. But what is important in the offerings that are at UCT is that we have got 20 majors. You might be wondering what these majors are, and I'll explain the majors in a minute. So in the biology, earth and environmental sciences, we have got 7 disciplines: archaeology, biology, environmental and geographical science, geology, ocean atmosphere science, marine biology, and lastly, quantitative biology. So what perhaps you see on the picture there is the oceanography group that usually go on the cruise to try and understand the marine world. I'm not going to explain all of these disciplines one by one, but some of them might be related to what you've done at high school by now. So you will know what biology is, you will know what geography is. Geology will be an offshoot of what at high school will be physical geography, but perhaps more deeper than that. And you have got your ocean and atmosphere science, which specializes in the study of the atmosphere and the oceanic circulations. Some of these things, of course, might be new to you. But we also have in the chemical and molecular and cell sciences 4 majors, and these are biochemistry, chemistry, genetics, human anatomy, and physiology. So if you're interested in those areas, you will find them in the cluster. In the mathematical, physical, computational, and statistical sciences, we have got 9 majors. And these are astrophysics, applied mathematics, physics, mathematical statistics, and computer science. But in order to do these courses, of course, you will need to have core majors with computer science. We can explain that later. One of the aspects that we've developed more recently at UCT is in the area of astronomy. Well, we all know that as a country, we have invested so much in astronomy. And at UCT, we play a key role in this national project. So on the picture, you have got students who can use telescopes right on campus. And these are connected to much bigger telescopes in many places around the world. We have just opened one last year on campus, and that's the excitement that it brings in astronomy. And we're beginning to see some results from this. I'm sure if you see on the picture, these are people who are sort of at the top of the building, and that's where the telescopes are based. Now, you don't have to do all of these things that I've just shown you. You will need to structure them into 3 years and make choices. So in the first year, you could take four subjects. I'll call them subjects for clarity. And in the first year, you will need to then think of what courses will be your majors. Your majors are courses that you're going to do from first year to third year. All in all, you will have done nine courses. You could split them into some half courses, and those will be 18 half courses. But I think 9 courses give you a good idea of what you expected to do at first year, second year, and third year. So as you go up, courses become fewer. Well, the reality is that you do much work as you go higher. So courses are fewer because the load that you have to carry is higher than what you have at first year level. So the question, of course, is now, how do you choose your majors? There is no simple answer to this. What you would need to do to choose the major subjects or major courses, as we call them at the university, is to first find out what you are interested in. The university is the interesting place in the sense that you have got to make some choices. Well, at high school, there are certain subjects that you have to do because they are part of the grouping of what you have chosen to follow. If you're doing the natural sciences, there are subjects that you have to do in order to succeed in the grouping. But at the university, you have a choice of which subject you want to group together. And that is the beauty of the university. People who have been able to choose the courses that match with their strength have been successful at the university. Not so much because they work harder, not so much because they are super intelligent, but because they're able to match their strength with their interest. It's very difficult to keep learning something that you are not interested in. So I would say the first factor to consider in choosing the majors is to find out what you're interested in and pursue courses that will interest you. That will make you successful at the university level. But sometimes we're interested in things that we can't do, and that becomes an issue. So it is important that you should choose the majors that you're also good at. If you're good in a particular field, that gives you the prospects of succeeding at the university. But sometimes people have to choose things that they are not good at because they think they are important, for careers, or because their parents think that they should do them. But it will also be important to make the choices on the basis of the kind of work you like to do. You might not know what you want to do at first year level, and that's understandable. Many people did not know what they were going to do when they were doing first years. Of course, there are few maybe who knew their way from the first year, first day at the university. But many people have to find their way. And one of the methodologies of finding your way is to begin to think of what is the kind of work that I want to do. Do I want to work where there are people? Do I want to work where there are only machines? And again, if one uses the example of computer science, where there's quite some innovations in modeling, whether it's modeling the spread of diseases or modeling human behavior. You spend much of the time, of course, doing the modeling on computers. It may be that you are interested in that kind of work, and that will work for you. So there are many other reasons that one can use to determine if you really want to pursue some majors. Of course, there's always a question of what will I do with a science degree. A science degree, it's more open-ended, perhaps more than other degrees. So if you do law, you know that you're going to be a lawyer. And straight from your first year, you will know that the end result will be your qualification as a lawyer, and then you will defend people in court. You will defend companies in court if you specialize on, commercial law. But with science, it's open-ended. So the BSc degree allows you to move to different spaces. That might appear to be a weakness, but I think the strength is that it gives you the chance to choose what you want to do. Let me give you an example. There are students who come to the university, and from day one, they see themselves as going to be doctors. And after some time, they might realize actually that's not where they want to go. But the degree has already put them on that track. But the BSc allows you to move in between the track. And you could follow a number of careers. I've just listed a few of them here, which is research, where if you're interested in pursuing research, then you can follow that career. Most of our students have gone into industry because of the kind of courses that we offer. Or you could have your own business. And so there are a number of things that one can do. To pursue a research career, you would of course need to have more qualifications after the BSc. Now, I don't want to go into details about the careers, but I thought I will need to explain what the BSc degree looks like compared to many other professional degrees. And of course, one can pursue the BSc degree and change to other degrees, and that's the beauty of being at the university. One can have a major in a particular discipline, but thereafter think that the major might lead to something else. And I'll give an example. There are specialists in climate systems who have studied, say, mathematics, and then they realized that they could use mathematics to do climate systems or modeling in climate systems. The students have done statistics, and then they realized they could use statistics for the health sciences. So there are opportunities to move in between here. What I'm emphasizing is that you are not locked into a particular path when you do a BCA degree, and that's an important part of this. And of course, there could be a number of questions that you have related to the presentations that you have just listened to, and these questions can be attended to by our faculty. There are also specific queries that are related to international school living and examinations, and you would have you could follow up on these questions. The emails are not very visible on the screen, but we do have contacts whenever you want to make follow-ups. I cannot perhaps end my presentation without wishing our grade 12 every success in the examination that's coming up. And now you will have the opportunity to ask questions, and we'll try by all means to answer them. I thank you very much.
I have been responding to the questions in the live chat. So if anyone has any questions that they are not absolutely clear on, could you possibly, re-ask those, because I have been trying to keep up by answering the questions as best I can. Manu, there's one question that is being put in the chat for you about the advantage of studying at UCT compared to some of our competitors.
Okay, that's an interesting and challenging question to.
Yes.
Well, we pride ourselves as a university that is at the cutting edge of science. If one looks at our global positioning as a science faculty, we actually compete favorably with science faculties in other countries that we consider to be highly industrialized. So the advantage will be to have exposure and meet some of the scientists who are on the cutting edge, at the cutting edge of research. And that will be the beauty of being taught by award-winning, professors. And as a university, we're leading university in the country in many areas. We are the top university on the continent, and we compete favorably globally. We do also have a rich network with other universities around the world, which gives our students the opportunity to go and learn in other places. So that's what UCT offers. It's the rich experience that you will get, not only from UCT, but there's an opportunity for excellent students to gain experience from other places. But I will say, a compelling reason is we're the best in the country. We have also shown during this pandemic that we are agile, we are resilient. Before many other universities were able to assist their students, we were taking the lead already. So that's it's perhaps a more compelling reason to come. Thank you, Karen.
Thanks, Manu. I see that there's a question there's quite a number of questions regarding transferring to MBCHB. And that is a very common question that we receive during open days generally. So I'm going to just quickly speak to that generally, so that it will respond to a number of questions that are in the chat. So a lot of applicants who cannot get into MBCHB will then register in one of the other faculties, either in science or in humanities or commerce or engineering or any of our faculties. There's no one faculty that will increase your chances of being accepted into MBCHB. So the advice we give you is to choose an area of study that you know you can do well in, and that you will enjoy, because it could be what you will carry on studying in should you not be accepted into health sciences in subsequent years. So you should make that choice and do your best. You have to be happy in what you are studying and then perform as well as you can. And that's all that's the only advice we can give you. We don't make the selections for MBCHB, so it is done, and we see a number of our students that do get accepted. So it is possible, and at any level. People have asked, is it only after first year? You can reapply every year, and it's you stand a chance, as with anything else. The problem is that they don't take the courses that you have done into account, but that doesn't seem to be a problem for most people who are wanting to move across. So I hope that answers all the questions that relate to using a different degree as a path towards the MBCHB. There is nothing that will guarantee you acceptance or increase your chances of being accepted. And then there's a question about what is the difference between mathematics and mathematical statistics. So mathematics is pure maths, and the mathematical statistics is actually statistical sciences, but we have two different branches of statistics. We have mathematical statistics, which is the more mathematical version of stats, and then we have applied statistics, which is just applied, and there are a lot more real life examples associated with it. I don't know, Manu, if you want to add anything to that?
Yeah, I can add. If one thinks of applied statistics, and this is where modeling is a good example of applied statistics, where you can apply statistics to your statistical knowledge to solve problems. But mathematics could just be, as Karen said, pure mathematics. You just do it because you like it. You're not necessarily going to use it. Although there's a branch of mathematics which is called applied mathematics, and usually applied mathematicians and statisticians find each other because they are working in the applied sciences. So if you're interested in solving problems, you can use some of these applied sciences to solve those problems. And so that's the main difference. It's how they are used, but they all depend on the basics in the first instance. I hope that clarifies the question.
Thanks, Charmaine. Yes, there's a question about, Manu, I'll read it out to you. Should I want to further my studies after my undergraduate studies into postgraduate studies, how long would it normally take to complete my PhD? So that is, I assume, after undergraduate studies, how long to completing a PhD? So would you like to answer that one?
Yeah, it's an interesting question. It takes different years for different people, depending on how fast they run. So I would say that a 3-year degree for BSc and an honors degree, which is 1 year. Then there's a master's degree, which can be completed in 2 years. But if you're brilliant, you can upgrade your master's into a PhD, so that you shorten the years up to PhD. But it depends very much on the pace at which you are able to complete these degrees, and the dedication, of course, that you have, and the passion that you demonstrate. So it could be, if you just count the number of years for each degree, 3 years for the BSc, 1 year for honors, so you've got 4 years there, master's is 2 years, and the PhD is normally, in between 2 and 3 years. But I would say those who complete the PhD faster are the brilliant, dedicated, passionate students who are able to upgrade their masters to a PhD, and that shortens the journey. So that will be my answer, Karen.
Thanks, Manu. There's another question about, do I need to be a good programmer to do well in computer science? So I think I can answer that quickly in that I don't think computer science expects students to already be good programmers. They teach you from scratch. So students who have not done any programming or you're not required to have taken information, the IT at school, because they will teach you everything you need to know from first year. So as long as you have an interest in programming, that's all that's required.
Yeah.
Just
yeah, I have nothing to add there, Karen. I think it's more the interest that you have. And yesterday I attended an address where the computer scientists are beginning to say the programmers always have to come and clean up what somebody else had messed up. So that seems to be a general trend in programming, but I'm sure it's about innovation. I wish we had more time, but we will need to answer the take the last question maybe.
Okay, let's just, I know we have run out of time. So there's a question of what is MBCHB, and that is what we call the qualification that trains you to become a medical doctor. So I hope that answers that one quickly. And then I think the rest of the questions we will have to respond to in a different way. Possibly could we get advice from Charmaine?
If you have an email address that you want to share, alternatively on one of your social media platforms.
Okay, now I'll add the email address because I see it didn't come through on Manu's slide, so I will add it and people can send their queries there.
Okay. Okay, thank you. I think we should wrap up the conversation. It was good to have this conversation virtually, which we enjoyed, and that's the beauty of science. We can use science to solve the problems, and this is the first time that we have the virtual meeting. Thank you very much, and have a good day.